My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 267. In this lecture, we will try to understand classification model. In order to understand classification model, first we will try to understand what is classification. What is classification? This is first point. Second point, how classification works. How classification works. How classification works. Let's take our Amzon fine food review. Fine food review dataset. Let's take our Amzon fine food review dataset for what purpose? For classification. For classification. Whereas we used MNIST dataset for to understand PCA and Disney. Now we will try to make use Amzon fine food review dataset for classification. We have multiple reviews. Almost we had 5, 6, 8, 4, 5, 4 reviews, isn't it? Let me recall that particular dataset once. This is Amzon fine food reviews dataset, isn't it? This is lecture number 250. How many reviews? There are 5, 6, 8, 4, 5, 4 reviews. There are fields, columns, ID, product ID, user ID, profile name, helpfulness numerator, helpfulness denominator, score, time, summary, text, isn't it? These are different column names. These are different features. We have multiple reviews. How many reviews? 5, 6, 8, 4, 5, 4 reviews. For each review, we are using the review text. For each review RI, we are using the review text, isn't it? We felt that the review text is most informative. Review text is the most informative feature. Most informative feature, or I can say most informative variable, isn't it? Each text we converted into a vector. RI means review, in which you have text, and each text is converted into vector by using techniques like bag of words, by using techniques like TF IDF, by using techniques like word to vec. We already discussed these techniques in our previous lectures. We learned multiple techniques for how to convert a text into a vector. Now for each review, I have a vector. For each review, I also have the data, whether it is positive review or negative review. Just refer my previous lectures. What is classification all about? The problem of classification is this. This is very, very important. This is the crux of the whole of machine learning algorithms, which falls under classification. So now we have how many reviews? 5, 6, 8, 4, 5, 4 reviews. For each review, we have vector representation, and we also have whether review is positive or negative. Let me write it otherwise. Just let me say how many reviews. There are 5, 6, 8, 4, 5, 4 reviews. These are the reviews, isn't it? For each review RI, I have vector representation xi, and also I have whether that review is positive. I have information whether that review is positive review or negative review. This is the data that we have, isn't it? This is the data that we have. Now, what classification, what is the meaning of classification in this data? The classification is all about, classification means, classification is all about finding the function. Classification is all about finding the function. Finding the function. What does it mean? Classification is all about given a new review, given a new review, given a new review text, review in the sense, given a new review text, determine. What you have to do? Determine, or I can say predict. Determine or predict. Determine or predict if the review is, positive or not. If the review is positive or not, isn't it? Review is positive or negative. This is the task. Review is positive or negative. This is the task of classification. This is the task of classification. Why it is called classification? Because given a new review RQ, means that is query review. Given the query review RQ, whether it is positive review, it must decide, it must tell us whether it is positive review or negative review. We are classifying a new review into two classes. First class is positive class and second class is negative class. That's why it is called classification. The classification can thought of. Let me write otherwise. The classification can be thought of as a finding. Classification can be thought of as finding a function. Finding a function y equal to f of x, isn't it? Let me explain what it means. Let me say finding a function y equal to f of x. That is classification, isn't it? Actually, most of the machine learning is about finding function. Most of the machine learning about finding this function. Finding f. Finding, I can say f. What does it mean? Let me explain that. Let me connect these two mathematical dots. So imagine each review is represented by a vector called xi. Each review is represented by vector xi. Every data point or every review is represented by mathematical vector called xi, isn't it? Given an x, I want to find a function. I want to find a function. I want to find a function f. I want to find a function f that will return. That will return a y. That will return a y for you. That will return a y for you. What is y here? What is y? Y means, y is whether review is positive. Y means whether review is positive or negative. That's what it says. Y is whether the review is positive or negative. What is x here? X is review text. X is review text. isn't it? Let me write it otherwise. Just let me write like this. What does it mean? Y equal to f of x. What is x? X is review text. X is review text. What is y? Y is whether review is positive review or negative review. So mathematically speaking, my classification objective of my classification is all about finding a magic function. Finding a magic function f. Magic function f. I will repeat. Objective of my classification is all about finding a magic function f. Finding this function f. Find this function f such that given a review text, given a review text, if I apply this function, if I apply this function f on a review text x, I would get y, which says whether the review is positive review, whether the review is negative review. I would get y, which says whether the review is positive or not. This is the crux of this is the central point, this is a central concept of all machine learning algorithms. I can say y equal to f of x, x is review text, and f is function, this y is whether it is positive review or negative review. Let's call it, let me say specifically, it's about given a new review. Let me say this is given a new review xq. What is f of xq? Isn't it? This is basically xq is query review. What is xq? It is query review. Isn't it? Yq equal to, I can say yq equal to f of xq. Isn't it? Yq should say, this yq should say whether it is positive review, whether it is negative review. We will try to understand this in detailed manner. Let me rewrite this one. How can I rewrite? Just say this one. Let me rewrite. Yq equal to f of xq. What is yq? It is positive or negative. What is this xq? Query review. What is this? This is the problem that we are trying to solve. This we have to find this f, isn't it? We are trying to find f, isn't it? In most problems of machine learning, not all the problems, there are problems which are not exactly this, but classification is all about your YQ takes few classes. This YQ takes few classes, but in this context, it takes two classes. In our case, what are classes here? One is positive class and another one is negative class. How does classification algorithm works? Let's assume this is your classification algorithm. This is my classification algorithm, isn't it? Let's keep it as a block box right now. Let's not worry what it's there inside. You give it something called training data set. Let me say here I have training data set, isn't it? Training data set. I am giving to this particular, this is, let me say, my classification algorithm. Let's not worry what it's in there inside this box. Let me keep it just like a black box. You give it something called training data set. When you give this data set, the algorithm your training data set consists of all of the pairs. What you can see in training data set? You can see pairs xi comma yi. Let's say I equal to some 1 to 200k. That is data set x1, y1, x2, y2, so on, x200k to y200k. Isn't it? What is my xi? Xi is review. Xi is review. What is my yi? My yi is positive or negative. Positive or negative. Now algorithm will take all of this input. This particular algorithm will take all of this input, isn't it? I will repeat. Now algorithm will take all of this input. This is called training data. This data set is known as training data because algorithm trains on this data. Here you are giving xi and yi both. You are giving xi and yi both. Now algorithm learns the function f. Algorithm learns the function f. That you must understand. This point is important. Now algorithm learns the function f because it is seeing lot of examples, right? Isn't it? It's seeing so many examples xi comma yi. We are seeing lots of example xi comma yi. By looking at all these examples, algorithm learns the function f. Let me rewrite this one. Let me say like this. I have what I am trying to find. I am trying to find function f. Yes, this is my algorithm, isn't it? After learning, what will I get? Let me say this is my training data. Training data. What is my training data? Xi comma yi, isn't it? After learning this function, what is the result of training? Training is you will learn function. If I give after learning, isn't it? After learning this function f, after learning this function f, how you learn this function f? By using training data. If I give it to any new point, xq, let me say, to whom am I giving? To f, it will return yq, isn't it? If I give it any new point, it will return me corresponding class yq. This is the crux of classification. This is how classification works. This stage is called, let me write. How can I write? This stage is called training stage. This stage is called training stage, isn't it? This stage is called testing stage, or I can say evaluation stage. Evaluation stage, isn't it? This I can say like this. In the case of training, what we have, let me say there are n points x1, y1, x2, y2, so on. Let me say xn, yn. This is my training data, isn't it? Now using all this data, we are trying to learn function f. We are trying to learn a function f such that we are trying to learn function f such that yi equal to f of xi, isn't it? Algorithm learn the function f. This algorithm learns the function f by using training data. Once if it learns the function, then our training is over. Once if you are able to learn f, your training is over. Now in test, this one is test. In test, I can say now in test or evaluation stage, we give it a new point xq, that has not seen. xq that has not seen. Remember, this xq may not be there in your training data set. If you give give it to a new data set, it can predict YQ accurately. Then we can say it learned the right function. If it is giving right YQ, correct YQ, I can say we learned right function. It learned the right function. Of course, machine learning is not perfect. It will not learn the perfect function. It will try to do its best job using various techniques. Of course, some techniques will be able to learn better functions. Some techniques will be learn worse functions. But this is the core idea. This is the main idea. This is the important concept behind classification. Just go through these points. These points are very important. Once if you understand these points, I will discuss about what is data matrix in machine learning algorithms. In the context of classification, I will discuss about data matrix notation in my next lecture. Thank you very much.